All right, let's dive right into this explainer. Today, we're building your toolkit for transforming AI from, well, what often feels like a wildly frustrating magic 8-ball into a highly reliable, collaborative developer. If you've been struggling to get consistent, top-tier results from large language models, you're absolutely in the right place. We're cutting through all the general hype today. No fluff. We're focusing purely on the raw engineering mechanics of how you actually talk to these systems to get exactly what you need.
So let's be real for a second. Think about your own recent interactions with an AI model. How many times have you typed out this carefully thought-out request, hit enter, and then just immediately sighed at the generic, fluffy, downright unhelpful garbage it spit back out? It's so frustrating, right? You know exactly what you want in your head, but somehow the machine just isn't getting it. It kind of feels like the AI is just being lazy, or maybe it's not smart enough for your specific technical problem. But well, the truth is actually a little harder to swallow. It really starts with looking at what we're actually typing into that prompt box.
And that brings us to the core engineering philosophy we're anchoring to today. A vague prompt is a vague spec. Seriously, if you hand a human engineer a poor, loosely defined set of instructions, you're guaranteed to get poor, loosely defined work back. An AI model operates on the exact same principle. Remember, large language models are, at their core, prediction engines. They are literally predicting the most likely next word based directly on your input. So if your input lacks detail, the output basically has no choice but to fill in the blanks with probabilistic guesses. The secret to fixing this isn't crossing your fingers for a smarter AI in the next update. It's writing a stricter, more professional spec right now.
So here's our blueprint for today. We've got 4 main items on the agenda. First, the anatomy of a prompt. Second, zero-shot versus few-shot. Third, chain-of-thought reasoning. And finally, the iterative execution loop.
Let's kick things off with Section 1, the anatomy of a prompt, building the base architecture.
Okay, let's look at a real-world example straight from our source material. Imagine a back-end developer, let's call him Sam. Now, Sam just got out of this highly technical, honestly kind of messy system design review for a checkout service rewrite, and he just wants the AI to draft a quick follow-up email to his team. So Sam types this: write an email about the design review action items. Guys, this is a classic zero-context prompt. The AI has no clue who Sam is, who his audience is, what the action items actually were, or even what tone to use. It's a completely blank canvas, and when you're dealing with a prediction engine, handing it a blank canvas is an absolute recipe for disaster.
So how do we fix this? Well, we don't just throw a few more random adjectives at it. We apply a structural methodology called the RCTFC framework. Now, I really want you to think of this exactly like writing a rigorous JIRA ticket. We all know what happens when you write a terrible JIRA ticket that just says, I don't know, fix the login button, right? A human engineer is going to spend hours going down the wrong rabbit hole, asking a million clarifying questions, and your sprint velocity just tanks. AI does the exact same thing, it just does it way faster. You've got to treat the AI like a brand new contractor who needs a strict, well-defined spec. To totally guarantee quality, we use this RCTFC framework to lock down specific variables. It stands for role, context, task, format, and constraints. By defining the exact persona the AI should adopt, feeding it the necessary background context, giving it a single clear verb for the task, dictating the literal physical shape of the output, and setting firm guardrails, you completely eliminate the AI's ability to guess. Every single letter in this acronym acts as a structural wall, keeping the model from wandering off track.
Let's actually apply this base architecture directly to Sam's task. For the role, we explicitly tell the AI, you are a back-end developer writing an internal follow-up email to your tech lead, Maya. Boom. Persona and audience, locked in. For context, instead of letting the AI hallucinate random project details, Sam literally just pastes in his raw, messy notes from the meeting. We're talking fragmented bullet points about rewriting the cart service, using Postgres for orders, debating API rate limiting, the whole shebang. And this is a super crucial point. You absolutely do not need to write a beautiful, polished essay for the AI to understand you. Just feed it the raw data. Pasting in fragmented notes works perfectly, as long as the framework around it is strict. Next, by locking down the task, format, and constraints, we force total relevance. The task itself is pretty straightforward, right? Write the email. But check out the formatting limits we place on it. We demand a specific subject line, exactly a one-line summary, a maximum of 3 concerns, and exactly 4 open questions formatted as bullet points. Then the constraints take it to a whole new level. We tell the AI to sign off as Sam, use a direct peer-to-peer tone, and we include this brilliant little detail. Maya reads emails on her phone between meetings. I mean, wow, that one tiny piece of context completely changes the output.
It forces the AI to ditch those long, rambling paragraphs and heavily prioritize scannability.
All right, moving right along to Section 2, zero-shot versus few-shot, context modifiers.
So even with a perfectly crafted RCTFC prompt, sometimes you need the output to match a highly specific internal company template that's honestly just way too hard to describe in words. This is where we contrast zero-shot prompting against few-shot prompting. Zero-shot prompting means you're relying solely on your written instructions. You're giving the AI a list of rules and asking it to build the output completely from scratch. Few-shot prompting, though, that changes the game entirely. This is where you provide 2 to 3 concrete, perfect examples of what you want directly inside the prompt itself before asking it to complete your actual task.
Think of it this way. Showing an AI 2 or 3 examples is exactly like showing a new contractor your team's best pull requests to teach them your unique coding style. Our source material notes something really profound here. When output has to match a specific template, the examples are the instruction. Honestly, it's so much faster for a model to mimic an example than to parse a complex 10-sentence paragraph of weird formatting rules. If you want a JSON payload structured a certain way, or a weekly bug report that needs to look exactly like last week's report, don't try to describe it. Just paste 3 perfect examples right into the prompt and let the model recognize the pattern.
Next up is Section 3, chain of thought reasoning, unlocking deep analysis.
Okay, so when you ask an AI a highly complex technical question, its instinct is to try and predict the final answer immediately. But just like a human engineer, jumping straight to the conclusion often leads to really obvious, avoidable errors. We need to frame multi-step reasoning through the classic engineering lens of rubber duck debugging. You know the drill. When you're stuck on a difficult bug, explaining it out loud, step by step, to that little rubber duck on your desk forces you to articulate the underlying logic. And that almost always reveals the error. Well, we need to force the AI to do the exact same thing before it gives us its final answer. We accomplish this using a technique called chain of thought prompting. By simply appending the phrase, "think step by step" to your prompt, you fundamentally change how the model processes the request. Actually, scratch that. It doesn't just change it. It transforms it. Instead of jumping straight to the output, it generates its intermediate reasoning steps first. Let's look at a hypothetical. If you ask an AI, hey, which is better for our new app, Kafka or RabbitMQ, a standard zero-shot response is just going to spit out a generic list of pros and cons. But if you tell it to think step by step, it evaluates your specific throughput needs, traces the latency requirements sequentially, and derives a highly customized architectural recommendation. Forcing the AI to trace its logic out loud catches errors that a standard shoot-from-the-hip response would completely miss.
Finally, let's look at Section 4, the iterative execution loop. Operational mindset.
Knowing all these structural techniques is great, but we really need an operational loop to actually execute and refine these prompts on the fly. To succeed here, you have to shift your mindset. Our source documents make a fantastic, absolutely essential point. Prompting is debugging, not dictation. Just think about that for a second. Nobody writes a complex new feature and ships their very first draft of code straight to production without testing it, right? That'd be crazy. So why on earth would you expect to ship your first draft of a prompt and get perfect results? You shouldn't. You really need to approach AI interactions as an iterative development process, where the first prompt is literally just your version 1.
And here is your continuous execution loop for doing exactly that. First, write the initial prompt using your RCTFC framework. Second, read the output critically. Third, diagnose exactly where the AI failed. When you spot a failure, you act like a detective, mapping that failure directly back to one of your framework letters. Did it hallucinate a constraint? Did it miss the format entirely? Fourth, and this is absolutely the most critical step, fix one thing. If you go in and change the role, the context, and the constraints all at the exact same time, you won't have any idea which variable actually fixed or broke the output. Change one variable to isolate the issue. And finally, step 5, rerun the prompt. You just repeat this loop until the output matches your spec perfectly.
I want to leave you with this final, incredibly powerful engineering mantra from our source text. Specificity in, quality out. An AI agent isn't a mind reader, guys. It is a highly capable prediction engine that is just waiting for precise instructions. By mastering the base architecture of your requests, using few-shot examples to set clear templates, forcing multi-step reasoning for complex problems, and iterating exactly like you're debugging code, you can command these models with total precision. So the next time an AI gives you a lazy, vague response, I highly encourage you to stop and ask yourself, did the machine fail, or did you just write a vague spec? Thanks so much for joining me on this explainer. Start applying these tools to your prompts today, and I'll catch you in the next one.